Okay, so in this video, we are going to be actually working with Google Cloud and we will be doing stuff with Google Cloud. So instead of just randomly jumping into Google Cloud and their products, I thought it would be a better idea to actually make a goal and then look at the Google Cloud's products and see which one can help us in accomplishing that goal. So for today, our goal is to actually host a simple website in Google Cloud. So it should be pretty simple. We need a Google Cloud account and we need to launch a virtual machine where we can install our web server and host our website, and then we will be logging into the virtual machine and then do the configuration of our website, and that's pretty much it. So first of all, we will obviously need a Google Cloud account. Google actually offers a 3 months trial period with a $300 credit. So if you have a credit card, you can actually get a Google Cloud account for free, and you can actually do all of these tutorials in that for free for 3 months. So to actually get started, you just have to go to cloud.google.com and then just click on the get started for free and have your account signed up, enter your credit card details, and you should be good to go. So I have already done that and I already have a Google Cloud account. So I'm not going to be showing you how to create an account. So this is the Google Cloud dashboard or Google Cloud Platform dashboard. We're going to call it GCP instead of calling the full name Google Cloud Platform. So I have already created a project called DevOps from scratch, and this is where we will be working on all the future tutorials. So if this is your first time ever seeing a GCP dashboard, it can be a little bit confusing, but you will get used to it really fast. So if you click on this button here, we can see all the products that Google Cloud has to offer. And there is a ton of them, and if you go looking through all of them, it's possible that we would get confused and overwhelmed by all of this. So I would suggest not to worry about it, but take a look at it anyway. Personally, there are a lot of services in here I know nothing of. It's completely okay for you to not know everything, so don't worry about that. So here you can see that they have organized all of these services into different categories. First of all, there is compute, and then there is storage, then there is databases, networking, operations tools, a lot of things actually. Right now, for our use case where we need to have a virtual machine to host our website, this product is what we are interested in. It's called Compute Engine. So Google Compute Engine or GC is a service where they will let us create a virtual machine of our choice, and we just have to pay for the resources that we use. Let's go ahead and launch our first virtual machine in Google Cloud. So for the first time when you click on this Compute Engine, it would show that you need to enable this GCE API. So there should be a button that will show enable API. You just have to click it, and in a few seconds you should be able to see dashboard like this. We can see the actual product name here, which is Compute Engine, and we can see all the subcategories that we have available in Compute Engine. We are interested in these VM instances where we can create virtual machines, right? So if we click on that, we will be back to the same menu. Okay, so let's go ahead and create one. So click on this create instance button, and this is the menu that we will use to create our virtual machine. So first of all, we need to give it a name. So we'll just give simple website, and don't worry about labels. Another thing is we need to choose a region. So what is a region? So region means where exactly this data center is located in the globe. So if you click here, you can see that it shows each of these continents and regions in each of these continents. So in Americas, we have a US East, West, and US Central. Then there is Europe, Asia. Basically, this actually corresponds to the data centers Google have across the globe. Which region should you choose? Well, it totally depends on our use case. So ideally, we want to have a data center that is closest to our customers. So if you have most of your customers from the US, then obviously you would be choosing something in the US East one or US East West or whichever data center that you think would be ideal for your customers. And if you have your customers in India, we can choose the Asia South one, which have a data center in Mumbai. Since I am in India right now, I'm gonna go ahead and choose Asia South one as the region. So now there is another option here called a zone. So a zone basically means that it's an isolation inside a region. For example, here we can see that there are three different zones in Mumbai region. So that means there are 3 different isolated data centers or resources in this Mumbai region itself. The reason for this is for redundancy. Like even if one of this whole data center goes down, there should be the other 2 available so that your applications can still run in the other 2 zones if you have redundancy, which we will talk about in the future videos. But for now, just remember that the zone is more of an isolation within a region. So it doesn't really matter to us which one we choose, but if you are launching more and more VMs, and if they need to talk to each other, we should be choosing a zone that should be consistent. So I'm just gonna choose Asia South 1A. No specific reason, just choosing the first one. Okay, so here under machine configuration, there are three options: machine family, series, and machine type. Okay, let me show you something interesting here. So here, as you can see, under this machine family, there are only three options: general purpose, compute, and memory optimized. Here, if I change the region from Asia South 1 to, let's say, now we can see there is another option called GPU. Different features may not be available across all the regions, so it is important for you to figure out which features that you need in advance and then stick to that region. So if you want a GPU, then you need to be in US Central 1. Okay, so back to the machine family. So we have general purpose, compute optimized, memory optimized, and GPU. General purpose basically is the one that would be applicable to us. Compute optimized means these machines are designed for high CPU activities, and it should be ideal if your application is very CPU intensive and you need to have the best CPU performance available. Memory optimized means that if you want terabytes of memory, you need to use this. See, you can have up to 3.75 terabytes of memory, although that's going to cost a lot of money, but it's an option. And if you need a GPU for your workload, then you can choose this option, and that's going to cost $2,600 a month. But the option is there if you really need it. Obviously, we don't need the $2,600 a month machine, so we're just going to stick with the general purpose. There is another option here called series. So you can see there are E2, N2, N2D, and then there is second generation and first generation. These are different kinds of physical machines that are powering these virtual machines. So if we take a look at this table here, we can see the actual difference between these machine types. So if we take a look at this E2 versus N2 here, we can see that CPU architecture itself is different. One have Cascade Lake and the other ones have like a Skylake, Broadwell, Haswell, etc. And this N2D will have AMD EPIC CPUs only. And then there is also difference in terms of features such as local SSD supported or not. So to keep things simple, if we are unsure about any of this, just click on this E2. That's the best option for us. The next thing that we need to do is a machine type. So which machine type should you have? It totally depends on our use case and our needs. How much of a resource your application is going to use depends on your application and how many people will be using it, etc. So there is no hard and fast rule on choosing this CPU, number of CPUs and memory. So for our use case, since we are just learning, we're gonna just go ahead and do E2 micro. But a thing to note here is that this E2 micros and E2 small and E2 medium have shared CPU cores. Shared CPU core basically means that we are not actually getting a full CPU core. If you have worked with VirtualBox, you would know that in VirtualBox settings, you can actually assign number of CPU to each virtual machines. If your computer have 8 cores of CPU, then you can assign up to 8 cores of CPUs to your virtual machines. In that case, each of those will be actual physical CPU cores your physical computer has, provided if it actually has 8 physical CPU cores. But when it comes to a shared CPU, we are not really getting a full CPU. As the Google Cloud's documentation says, E2 micro means we will have 2 virtual CPUs with only 12.5% of the CPU time. Basically, we will only be getting 25% of a full CPU. That means if we do the math, if we fully utilize these 2 virtual CPUs, then it's gonna have only 25% performance of a one actual full physical CPU. In our use case, this is actually fine because we can see the price difference here. If we go with a E2 micro, it's gonna be $7 a month. 2 CPUs and 1 GB memory. But if we actually go with this standard one that actually provides a full CPU instead of a shared CPU, we can see the price jumps from $7 to $50 here. So this shared CPU is totally fine for our use case. But if you're actually running production website, if it's your company's product that actually needs to handle a lot of traffic, then do not use these shared cores. Actually go ahead and use the actual dedicated CPUs in any of these standard options because that gives the best performance. We're gonna go ahead and stick with E2 micro, and it's gonna cost us $7 a month. Okay, so the next thing that we need to take a look at is boot disk. So if you click on here, we can actually choose what kind of disk this virtual machine should boot with. So under these public images, there are a lot of operating systems available like Debian, CentOS, we have Ubuntu, we even have Windows servers available. Depending on your use case, we will be using an operating system from this list. So I'm gonna stick with Debian because that's what we are familiar with. And here we have to choose the boot disk type. So balanced persistent disk means that these disks are like, slower, spinning disks like the HDD in our laptops. If we want better performance, we need to use SSDs. The pricing can differ based on how much storage you're actually using. So I'm just going to go ahead and use SSD. This means like how much disk size your boot disk should have. This also depends on your application and how much data you will be storing on the server itself. 10 GB is not gonna be really good enough if it's an actual production server, but in our case 10 GB is plenty because we're only gonna have a simple website. In here you can actually have other different types of images. Like this is the public images. This is the list of images that Google provides us from different distros like Debian and Ubuntu. We can actually import custom images, like we can have our own images created, which we will actually be using in our future videos. We can also boot from snapshots. Snapshots basically means like you can take a disk and create a point in time snapshot, meaning that everything in that disk will be available in that snapshot at that time. And you can use that as a boot disk if you want. Or we can also use existing disk and boot from it. But for now, we're just gonna stick with this public image because we don't have anything else. We don't have any we don't have any custom images or snapshots or disks. So we're gonna stick with this and click on select. The next option here is firewall. So Google Cloud by default does not allow outside access to any of our VMs or any of the services. We need to configure it using the Google Cloud Network Firewall. I will be talking a lot more about this firewall in the next videos, but for now, we only need to click these two buttons. We need to allow HTTP and HTTPS traffic from the internet. I'll show you what exactly this does in the next video. If we go ahead and click here, management, security, disk, networking, and sole tenancy, there are a lot more options that we can configure here. Actually, any of these, don't worry about it. For now, it's not of importance as of now. The default options are fine for us. Under security also, these are all not really important for us, but here we can actually provide SSH keys that will be allowed to access this virtual machine. So there is also another option to actually block project-wide SSH keys. That means in GCP, we can actually add an SSH key that will have project-wide access. We haven't done that. So here what I'm going to do is I'm going to paste my SSH public key so that I can access this virtual machine. So I already have an SSH key here. So I'm not going to create one. So I'm just going to copy the whole thing. So if you are not familiar with this, I would strongly suggest you to go ahead and watch my previous videos because we have talked about all of this in detail and I'm not going to repeat that here because it's going to take a lot of time. I'm just going to copy this SSH key and paste it here. So it automatically picked my username from this command here and should be good. So under these other disk options, there's nothing actually we need to change here and nothing to change here in networking as well. And nothing to change here in sole tenancy as well. We're keeping things as simple as possible for now, and we will come to all of this when we need them later. So click on create, and it actually failed because it says E2 instances do not support on host maintenance equal terminate unless they are preemptible. So I think this is some kind of bug. I did not change any options in the settings, but it's showing this. So I'm just going to dismiss this and create it again. Simple website. Asia South 1, South 1A, E2 micro. I'm not going to change anything in here because we didn't change anything. Allow HTTP and allow HTTPS traffic. And under security, we paste our SSH key. And that's it, create. Done. We just created our first virtual machine in Google Cloud. I'm just going to dismiss this. Here we can see that our first virtual machine is up and running. We can see the internal IP of the machine. We can see the external IP of the machine. If I click on the virtual machine, we can see the full details here. You should go ahead and read all of it. We can see the network, which is default, which we didn't talk about much, but will be covered in the next videos. So we have our 10 GB SSD. Oh, actually it's not SSD because I forgot to change that afterwards. and we have the SSH keys here. So it's all good. Now we can actually connect to this virtual machine via SSH. There are a few options here. We can open it in a browser window, which basically means that we can actually access the machine over SSH in a browser window itself, which is really cool. And here we can see that we have logged into the machine. So this will work even without the SSH key that we added. The reason why we added the SSH key is so that we can actually connect it without having to use this browser based client or anything. We can just use our terminal to do SSH and then username at IP address. Also, you can use other stuff like view this gcloud command that will be used to actually log in. So this we will talk about in another video. You don't really have to add the SSH key beforehand, but we can use this gcloud command to log into the machine. Anyway, we're gonna just go ahead and copy the IP address here, and from our terminal window I can do SSH-I IDRSA1 because this is the key I provided in GCP before. So you have to replace it whatever the key that you have provided. If it's just IDRSA, then you don't really have to specify the key, username at the IP address, and press enter. And we are in the virtual machine. Let's go ahead and install Nginx. And it is done. So let's go ahead and open the IP address in our browser and see what happens. And we see our Nginx web page. So I'm just going to take a look at where exactly the document root is for this installation. So for that, I will open etc Nginx sites enabled default. It's under var www.html. So I'm just going to create a file called index.html and save, and we have our website ready. Alright, so that's how simple it is to create a virtual machine in Google Cloud. The best thing is you can actually stop this machine and you will not be billed for it until you start it back again. So I'm just gonna go ahead and stop the machine. That's it for this video. In the next ones we will be doing more complicated stuff, and see you in the next one.